What's up, guys? We are covering the protocols and servers today, and we're going to go ahead, and this is the second in our box, but one thing I'm going to do different in this box, you guys will notice, it was actually a suggestion from one of my subs, and it was I've been trying to figure out how to fix this for a while, but basically they say my camera's in the way for the answers, and that's fine, but I would have rather had my camera in the way for the answers than I would for what I'm actually doing on the right side. And the reason for that is because I want you guys to try and do this yourself. I don't want you to just come and look at the answers. So what I'm going to do, which was a suggestion and a good one, is I'm just at the end, I'm going to show the whole box, all the answers, and then you can pause it, whatever. But anyway, that's just something that if you guys are looking for just the answers, which I don't recommend, you can go to the end of the video and you can actually learn that way. Or not, you won't learn anything, you'll just steal the answers. But anyway, all right, so this is Protocols and Servers 2. Hopefully you guys are enjoying the series. If you are, make sure you hit that sub button and the like button and comment below. It helps out a ton. You guys know how YouTube is. YouTube's algorithm only will show videos to people with a lot of activity. So without further ado, let's get into it. So we covered the first one. We did cover Telnet a little bit in the first one, but they don't really cover it as much in this, and that's fine. What we're diving into is this one's really not so much about the protocols and the servers. It's more about how to take advantage of them, which I like that idea. So firstly, it's talking about the CIA Triad. If you guys don't know about this, all it is confidentiality, integrity, availability. So what they're saying here is you need to, if you're hosting something like a website or something like that, you need a CIA Triad, meaning you need the information to be confidential. So if someone puts their social security number or their credit card number or something, it needs to be confidential, right? You cannot let someone else find that. You need integrity, meaning you can't let someone change the file. And you need availability, meaning when someone needs to access that file, it needs to be there. So it's a tough situation to play, right? You have to get right in the middle of that CIA triad. You need to get right in the middle of all three of them. Now, what they mean by that is, let's say you make it so confidential that there's no availability, right? So if I lock the file down so encrypted that nobody can access it except for one guy and it needs to be accessed by a bunch, well, you're losing the availability. So you need to find that middle ground for all of them, for the integrity, for the confidentiality, for the availability, okay? And this is something very well known in the cybersecurity world. So if you guys aren't familiar with the CIA Triad, definitely look into it. It's as simple as it sounds, but it's also a very tough web of things to weave together to try and make that perfect triangle when you're trying to actually implement something. All right, so this is just the intro. You guys can read that if you like, but we're gonna go ahead and start the sniffing attacks. So what a sniffing attack is, it's exactly what it sounds like. It's just somebody on your network or on whatever network you're on, and they're just listening. They're not trying to do anything. They're not trying to take stuff. They're listening. And what they're listening for is they're watching the network traffic to see, does someone type a password in clear text? Is there someone that's typing, a credit card number in clear text? So when you go to like McDonald's Wi-Fi or Starbucks Wi-Fi or whatever, and this isn't a diss on them, it's just any public Wi-Fi is what I'm saying. If you go to a public Wi-Fi place, there might be someone listening on those on that Wi-Fi, and that's what they're trying to do. And they're showing you here's 3 tools that are super easy: TCP dump, Wireshark, and T-Shark. Now, if you're any sort of network person, you probably are very, very familiar with Wireshark. But you can see here, this is all you got to do for TCP dump. So you just do sudo, which obviously, then TCP dump, and then whatever port you're going to listen on. Now you'll probably have to specify which interface if you have multiple or whatever. And you can see here that they added means they want to see all the characters in ASCII format, which is just meaning they don't want binary. They don't want ones and zeros. They want to be able to read what it's saying, right? So you can see here, they're getting all this character, but look, they get user Frank. And then you keep looking, and it says password required. Okay, boom, boom. And then there's the password. So they got the password and the username just by watching it go by. Now, there's a couple ways that people do this. Now, you might say, one thing I noticed, like when I first learned about this stuff a long time ago, one thing that you might notice is you're like, well, shit, I can't I can't decipher this because this is going to be scrolling by so fast if there's a lot of network on, or a lot of traffic on the network. So what do I do, right? Well, what most of the time what someone will do is they'll save this as a file, wait till, let it run for a couple hours so you're capturing that. And then they just search that file for a word like pass or password or username or user and see what names they can pull out and what passwords they can pull out, rather than sit here and actually just genuinely watch this for hours. Now you can watch it, and you can, if it's slow enough, you might be able to catch it. My guess is going to go by too fast, but keep that in mind. This is Wireshark if you guys haven't seen it, and you can see they're actually opening a file, a PCAP file, rather than watching live traffic in this instance, and they're searching for it. So this is where it's really important. You notice they got up here this search bar, it says POP. So they're searching for the POP3 protocol. Now, you notice they search for that, but you could search for pass and then just wait till you get the pass and see it, right? Now you'd have to search for user and pass to get both together, but it's important to know that you can, with Wireshark, it's a tool that's very easy to filter out different things, right? So this is just kind of explaining what listening is, or not listening, but what the actual sniffing is. But that's all it is. It's listening. You're just watching the network to see if anyone makes a mistake. And by make a mistake, I mean outdated protocols don't use security. They just watch things go in clear text, and you can get them. So this is why we recommend encrypting traffic on your network, even if it's just going from your computer to your neighbor's computer or whatever, to local computers. All right, so the first question, what do you need to add to the command sudo TCP dump to capture any telnet traffic? Now you can see here's our sudo TCP dump, and they added port 110, but they're not looking for telnet traffic. We are. So we need to add port 23 for telnet traffic, okay? Now, what is the simplest display filter you can use with Wireshark to show only IMAP traffic? Well, we see right here, they're looking at the POP traffic. So what if we just search IMAP? And there it is. That's the easiest filter you're going to find, and it's going to give it to you. All right, let's dive into man-in-the-middle attacks. These are probably the most famous and also the most fun attacks that you're going to learn about today. Man-in-the-middle, it's as simple as it sounds. Now, this is showing a server. What you could do if you're on the same network, or not even theoretically, you're typically going to see this more if you're on the same network. And the only reason I say that is because it's going to be harder to intercept someone on the internet, okay? If that makes any sense. And what I mean by that is, let's say A is a guy in Georgia, just make up something, right? And B is an Amazon server in, who knows, Japan, I don't know. You have to know what route it's taking and sit and intercept it. It's much more difficult than it is if I'm sitting on your network and I know that A over here has to go to their router first. Well, if I'm sitting on their network, I can say, hey, I'm the router. Come to me first. And that's what happens. What happens is it's DNS spoofing, ARP spoofing, all that stuff. What it is you're telling this computer that you're the route it has to take, okay? You have to come through me because I'm the router. I'm, whatever. I'm whatever you need, right? I'm this server, whatever you need. And you're telling it that, and when you tell it that, it sends the information to you first, and you use a tool like EtherCap or BetterCap, and you actually reroute it then out and tell this guy right here, I'm A over here. So the server thinks you're him, and he thinks you're the server, so they're sending the information back and forth through you, and they don't realize that you're there. So that is what a man-in-the-middle attack is. You're the man in the middle. They don't realize you're there, and they're sending all the data to you. Now, this only works, again, if you're using unsecure protocols. Because if you're using secure protocols, it doesn't matter if I get that information. Let's say I still pretend to be your the person you're trying to reach, your destination. That's great. You just sent me an encrypted file. Unless I was there for the initial connection and I captured the encryption, I'm probably not going to get it because we're using public key authentication, meaning this person, the destination, is the only person that can de-encrypt that, right? So what am I going to do? I'm going to get all these packets that are just encrypted and I can't do anything with them. So I'm just looking at jumbled letters, right? That's not going to help anyone. So you're not going to see this as often nowadays, this specific attack that they're showing, because of the fact that things are now very much encrypted and very secure technically. All right, so it's saying here they can also affect other clear text protocols like FTP, SMTP, POP3, blah, blah, blah. And mitigation against the attack requires the use of cryptography, which is what we just talked about. If you encrypt your stuff, it's much, much, much harder. Now, keep in mind you have to use a decent algorithm, or else, and all that is up-to-date stuff. If you're using some application that's from 2000, it's probably not using an up-to-date algorithm if it's not supported, and you're still vulnerable. Now, and like it says here, with the public key infrastructure and trusted root certs, so meaning with websites now having certs that are trusted, meaning that you don't have to worry if they're real or fake, you can easily tell if a website's real or fake, typically. All right. So, and it says transport layer security protects from man-in-the-middle attacks. And this is, you notice it says HTTP is the actual protocol that you're using here. Now, if you look here, see that lock right here? That lock is on almost most browsers now, and that means you're using HTTPS. So if I click here, you see HTTPS, which is HTTP secured. So it's, you're not that vulnerable to it. Excuse me. Excuse me. All right. This is the OSI model. If you guys aren't familiar with the OSI model, don't worry about it. This has nothing to do with what we're doing here. I'm not really sure why they show the OSI model here, other than to just show you that there's secure protocols right here in the presentation layer. But other than that, not really sure what they're trying to do with this model. But anyway, what we're doing here is all they're showing here is the transport layer security. So what that means is this transport layer, they're saying get security on the transportation of it, rather than if you just had security on the presentation layer, for instance, right? That would mean that it's only secure once it's being presented to me, but it's not being secured on the transportation portion. Now, we know that nowadays it is being secured on the transportation level, which we need, because if you're not securing it, meaning, let's say you encrypt something when it's stored, right? Let's say you've got it sitting on your computer and the file's encrypted, but as soon as you go to send it back and forth, all of a sudden it's clear text, right? Now, that might sound like a weird scenario to you guys, like, well, that would never happen, whatever. Well, think about like shared files, right? So a file that you have open, that then if someone else opens and you're typing in it, they can see it, right? That happens a lot. That happens in a lot of work environments. Well, what if you're typing passwords in there, right? But now it's clear text. The other person opens it up and they're seeing the passwords. Well, what if someone in the middle is watching that network traffic and saying, oh, there's the new password. You just type the new password. So it might be secured when it's stored, but as you're editing it and transporting that information, it's not secured. That's where you can run into some issues or some trouble. Okay, so, and it's saying here, because of the close relationship between SSL and TLS, one might be used instead of the other. However, TLS is more secure than SSL, which we know TLS is kind of the norm now, typically. And like it says here, it practically replaced SSL. So, yes, that's good to know. Now, here's the information that you really need to know. You have protocol, HTTP, FTP, SMTP, POP3, and IMAP, right? These are all unsecure protocols. Here is the secured version of them, HTTPS. Now we know this is the default port, but there's other ports you can use it. FTPS, SMTPS, POP3S, and IMAP-S. These are all the secured version of these protocols. So if you're doing something, use the secure version. Even if it's something that may not be important to you now, because let's say you build an application and it's only for sharing pictures and you think, oh, this is nothing, whatever, anything, right? Well, let's say 5 years from now, that same company goes, hey, we have this capability of sharing pictures, but we need to be able to share, passwords to the security team. Okay, well, let's just use what you already have. You have an application built for this specifically. We can already do it. Well, now you have to go back and change the setup because it needs to be secured. So I personally recommend using security all the time, unless it's something that you're really okay with someone being able to see everything. All right. So let's see. This is just telling you how HTTP works, and then here it's saying the difference. HTTP works. It establishes a TCP connection. Then it sends the HTTP request to the server, where HTTPS first establishes the TCP connection and then establishes the SSL or the certification connection, meaning they're going to verify each other, who they are, their existence, and that they're legitimate, meaning they were signed by a third party. So that's important. So you see here, it's showing that they're sending certificates back and forth. Those are digital certificates to say, I am this person, look. Well, that certificate is then checked with a certificate authority to say, is this person legit? And it's a third party who could care less what you do for a living, who your company is. They don't care about that. They're just saying, yes, that is a legitimate company. They are who they say they are. So you can then verify and say, that's who they say they are. I don't have to worry about it being a fake person. That's all it is. All right. And then here it's showing you how you can actually view the certs to see who signed it, things like that. And you can see, like, there's a lot of times they might be expired. And you can see the fingerprints, blah, blah, blah. Okay, cool. So here it's saying, yep, so you can see who this certificate was issued to, the name of the company. So that's another big one, the name of the company. So what that means is, let's say you're working with Amazon, and the name of the company that registered the cert is Hackers R Us, right? Probably not real. You know what I mean? So they might have really got a certificate signed, but the web server that you're looking at and messing with is probably not them. So keep that in mind. DNS can also be secured using TLS. So what's the acronym for DNS protocol that uses TLS? And it's DOT. DNS over TLS is what it stands for. And they expect you to do a little bit of research here because they're not giving you these answers. They expect you to kind of just look it up, right? And I don't think I covered the answers on the other one, the man-in-the-middle attack. Yep, I did not. How many different interfaces does EtherCap offer? And again, they want you to do some research. They have EtherCap and BetterCap right here. They want you to click on them. It'll take you to their web pages. And if you go to usage, you got 3 different modes. So the answers for both of them are 3. All right. Now, SSH. You guys are probably very familiar with SSH. It's actually used on Linux most of the time to securely administer or administrate servers. So what I mean by that is a lot of Linux servers will have SSH available, and the reason they do that is because it's a secure way to do administration to the server without having to physically log into the server. So this is just showing you some of the syntaxes and the passwords, right? But you can see the man in the middle. That's a real attack that'll happen if they're watching you type that in clear text. That's why SSH luckily is secured. And you can see, if it's first time you've logged in, you'll have to get the SSH server public key. And what that means is it's going to give you the information, the fingerprint, saying this is who they say they are, right? And you have to say yes, that's them, or no, it's not. Because if it's someone else, then you might think, or then you would have to know that, right? Because let's say this is the first time you logged in. Great, cool. Let's say you administrate with SSH every day. You're logged into the same server every day. You're adding stuff. You're taking stuff, whatever, you know. And then one day you log in and it says verify the authenticity of this cert. You're probably going to be like, well, why would I verify it? I do this every day. That's where you got to be a little cautious because it only asks you the first time you do it. So why is it asking me? Because it's the first time you logged into that server, meaning that you're actually not logging into the server that you think you are. So keep that in mind. It's important to just kind of know that stuff so that you may not have to do it all the time, but just if you see something out of the norm, you might go, let me look at this a little bit before I just start typing in passwords and stuff, right? All right. So here it's showing you how to use Secure Copy and SSH. You can use SSH and Secure Copy together, meaning you could SSH into the server and then Secure Copy using the SSH protocol. So here it's saying use SSH to connect to 10.10.174.30.35 as Mark with the password and find the kernel release. This is they just want you to see what they're talking about. So we'll go ahead and say SSH, and we'll say mark at. And if you guys don't know how to use SSH to log in, you just say whatever name you want at, and then whatever the IP is. And then you're just going to specify, well, we don't have to specify anything here because we're just trying to log in. It's going to ask for his password, which they give us. And you notice it didn't ask me. You notice it did not ask me about the security cert. That's because I logged into this before. Before I made this video, I logged in to make sure everything works. So that's how I know I've logged into this server before. This server is 100% the server that I already logged into before because it's not asking me to do anything. It just logged me straight in. Perfect. Well, then we'd have to go ahead and find the book.txt because the next thing it's asking us to do is use SSH to download the file book.txt and tell them how many kilobytes it is to download. Now, I'll go ahead and exit out of this, okay? And we're going to use secure copy. Now, SCP, and then we're going to say, excuse me, I'm not going to do it the way they do it just because I do it differently. So you can see here the way they do it, they put the document first. I like to do the person first or the login. And then from there, I will actually say, okay, we know it's in home, mark, and it's book.txt. Now, one thing you guys might get hung up on, if you just type this command, because you notice that's what they typed, it's not going to work. And I'll show you what it does here. You notice it gives you incorrect. You have to specify on your machine where you want it, okay? You have to. If you don't, so I'm putting it in the home. Now it's going to ask me for the category, or I mean for the password, excuse me. Sorry guys, I'm a little bit out of it today. So we'll go ahead and specify. And boom, you notice it downloaded. There it is. It's 415 kilobytes. And you type in 415, and that is the correct answer. All right. So that doesn't seem like crazy. It just kind of sounds like they showed you that how SSH works. But this is what they wanted you to see. They wanted you to see what it looks like, you know, how to detect if it's not necessarily real. And then here, you're going to see the password attack, how we could take advantage of something just like this, okay? So this is the man-in-the-middle attacks they talked about. We're not going to talk about those anymore, thank goodness, because I don't want to say beat a dead horse, but there's so many different man-in-the-middle attacks that it's such a generic thing. If you understand that you're just sitting in between the two connections and that you're intercepting and then sending out and pretending to be each other, then you understand man-in-the-middle attacks. There's so many of them out there that you'd have to dive into each one to really get what's going on, but the concept is the same, okay? Password attacks, on the other hand, they're totally different as far as from the man-in-the-middle attacks, but they're very well known. This is what a lot of people think's happening when they get hacked all the time. They always think, oh, well, someone got my password. Might not be true, so keep that in mind, but this is what you're going to see a lot of. If you work for like an analyst or a SOC or something like that, you're going to see a lot of spray attacks happen. So meaning you're going to see people spraying passwords at your users, trying to guess their password. That's what this is, okay? So you can see here, Telnet, blah, blah, blah. They need the password. All right, let's see. They're just showing, for some reason, they're just showing the login method. I'm not really sure. All right, so this is kind of interesting. It's very interesting. So based on 150 million usernames and passwords leaked from Adobe breach in 2013, these are the top 10 passwords. 150 million people, and the top password is 123456, and that's only 8, 9 years ago, depending on when it actually came out. 8 years ago. And the password's 123456. The next one is 12345678 I mean, come on. Password's the third, and you'd think with today's world and how things are going, this would change. A lot of people would think that, but I'm telling you, being in the industry, it's not changing. People are now, you can force people to add different characters to their passwords and stuff like that, but instead it's just going to be now 1 2 3 4 5 6 exclamation point, something like that, right? If they're not getting more complex, people are just dealing with what's required, okay? So what they're telling you here is there's on the attack box and on all Kali Linux boxes, including Parrot OS, which isn't a Kali box, but I'm saying it comes on Parrot as well, and some other boxes. This rocku.txt, hopefully you've heard of it. If you've been a hacker for a while, you definitely have. What it is just breach passwords or leaked passwords, however you want to say it. And it's a list of them I couldn't even tell you how many long it is, but it's a lot, and I mean a lot. I don't want to say in the millions because I don't know. I've never actually gone through and looked at how big it is, but it's definitely in the hundreds of thousands of passwords, I would say. All right. Let's see. So let's try to see if they said it on here. All right. So now we're going to show you an automated way to guess the password. So there's guessing passwords, right? Now I could do that, and what I mean by that is I could just sit here and guess. So I could just go, oh, blah, 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 and then if I know you well enough, I might be able to guess your password, right? If I know who you are and I know your dog's name is Charles and he's your favorite thing in the world, I could probably guess Charles 1 2 3 or something and get it right? That's one way. Then there's dictionary tags. Dictionary tags is where we're going to use, we're going to use this rocku.txt. Even though it's just a password file, it's still a dictionary, right? Because we're just guessing from a list of words. Now, brute force attack is different. Brute force attack is starting at 00001, 00002, 000, and going all the way up. Now, this is much slower, okay? And the reason I say it's much slower is because they have to guess everything, right? Now, I can tell you it's obviously eventually going to get it right if you brute force, okay? Eventually it will get it because it kind of has to. But the problem is it could take years, and I'm not joking. You could have your computer running on one brute force attack for a password and not get the password for years. By then it doesn't matter because that password's been changed, okay? So keep that in mind. The other thing to keep in mind is there is dictionary tags, and they are systemically slow, we'll say. And I don't mean slow. They're pretty fast, actually. But if you have a million passwords in a dictionary file, because what a lot of people try and do is they just try and grab password files like rocku.txt and throw them all together and make the biggest password file they can, and that's great. Problem is, let's say it's the last password on that file. You now have to go through all of them, and it's going to take days, okay? Which is still a long time, maybe even weeks. So there's dictionary attacks, but then there's also rainbow table attacks. If you guys aren't familiar with these, it doesn't cover them. I'm just going to briefly cover it. What it is when you do a dictionary attack, what happens is your computer stores the hash of a password, not the actual password itself. So what has to happen for your computer to guess the attack is your computer has to give it the password, right? It has to hash it and then compare that hash and the other hash and say, are these the same? If they aren't, okay, go to the next one, hash it. That takes computer processing power. So what a rainbow table attack is someone takes a word list like rocku.txt and they hash it before they save it into a file, meaning they hash every one of those passwords and then they save it into a file. And when they save it, now it's all hashed passwords. So now when you go to do something like this automated dictionary attack, it's going to send it the hashes, and it no longer needs to use that extra processing power to hash it. And I know that sounds like you're saving minuscule amounts, and you are, but when you do minuscule amounts over 1 million passwords, it saves a dramatic amount of time. So keep that in mind, but at the same time, keep in mind once you hash them, you've done the processing power beforehand, but you also have to have them saved somewhere, and the file's going to be bigger because the hashes are bigger. So keep that in mind. All right. So we kind of went off a tangent there, but that's all right. So we're going to use Hydra here. If you guys haven't heard of Hydra, it's a good tool for guessing passwords. And here's the syntax for it. Hydra, L, so the lowercase L is username. And you notice they're only showing the lowercase L and the capital P here. If you know the password but don't know the username, let's say someone leaked a password, you can also do a capital L and then use a username list. And you can do a lowercase p and use a password that you already know. The capital specifies that you're using a list of them, and here they're using wordlist.txt, and then the server and the service, meaning what server, so what IP address and what service are you using, FTP. Now you can actually, instead of using FTP, instead of typing FTP, you could say SSH, you could say whatever. And we're going to show you down here, and they show you here you can actually use the port. So if it's on a non-normal port, you can specify it that way. And you'll see here you can change how many connections in parallel you'll do. Now, the reason you might want to do this is because, for one, you're going to get busted if you have 50 parallel logins for the same person, right, trying at the same time. So stuff like that, just keep that in mind. These are password policies, account lockout policies, meaning that like most of people's account on a system locks out after 3 attempts. But the problem is with SSH and stuff like that, a lot of times they don't have lockout policies on that. And that's not necessarily a non-secure thing. The reason they do that is because these are for admins only. So not everyone's account has this. Number 2, if we lose SSH access to a server, those sometimes are local accounts too. So if you lose those accounts, meaning they get locked out, you may never get back in that server correctly, okay? So what we're going to do now is, and I think I have it saved here. Yep, so here's Hydra. Here's the actual command. We're going to say Hydra tac L for login. The name is lazy. We know that. It says it right here. And then the P, capital P, and then where is the rocku.txt? That's what we're going to use. So then that's the password list. And then we have the IP address, and then what service it's running, which is IMAP, okay? We hit enter, and you can see it's going to take a little bit to get set up. And it says here 16 tasks per one server, overall 16 tasks, meaning it's going to try 16 open connections at a time. And I know the password already, it's butterfly, but I want to see, oh, that's how fast it was. So now we can control C. We don't even need to do anything else. And you can see login is lazy, password is butterfly. And I think they did that on purpose because Rocku is alphabetized, I believe. So it was pretty quick. So we type in butterfly and boom. Now, keep in mind also, what you'll see sometimes is you'll see someone using instead of using login and putting the name, they'll use a login username and a password file and try all kinds of usernames and all kinds of passwords, just guessing, right? So that is a little bit louder, meaning you're going to get caught more than likely, but it's much more effective. Now, that's the box, guys. I'm going to hit submit here, complete, and then I'm going to go back and I'm just going to pull these up for you guys so that you guys can see the answers. All right. So this one, there is no answer. It's just correct. All right. This one we covered. But there's the answers so that if you guys aren't getting them, you can pause this. That way you guys aren't missing out on anything that if you missed what I typed or anything like that. So there's 3. Here's DOT, SSH. There's the actual kernel release, and then there's the size. The size is 415. I know you guys can't see it. I can see the cameras blocking it. And then the password is butterfly undercase. I know that you can't see it, but the password is butterfly. All right, and then if we need to, I can do this too so you guys can see. Password butterfly. And then secure shell. There's the 2 if you need them. And you could save it if you want to, guys. Or pause it, excuse me. Hopefully you guys like this. I'm going to try and do that. I'll try and get a better process for it. Maybe just take screenshots and put them up at the end. I don't know. But hopefully you guys like this box. It's pretty simple, but it's also very important, especially the password attack, because that's something you're going to see a lot of times in these boxes. Especially on Try Hack Me, they do a lot of brute force, a lot of dictionary attacks just to get your foot in the door, and then they'll have you pivot with a different type of account. So hopefully you guys like it. hopefully you guys are enjoying this series, and if you are, make sure to hit the like, sub, and follow button, whatever. I know that it's kind of tacky when people say that, but it is the only way that you can make your YouTube channel grow and get exposure to other people besides the people that watch your videos. So hopefully you guys like it. Keep suggestions coming. I definitely take constructive criticism, and I try and implement it if I can. So hopefully you guys enjoy this. This is a different format. It's kind of the same, but it does give you guys a little bit more chance to get the answers. So hopefully you guys enjoyed it, and hopefully you guys have a great day.